Okay, implicit differentiation is a technique that sounds scary, but it's actually pretty straightforward. It's a very algorithmic approach. Do you understand what I mean by the term algorithmic?
Nope.
It's like following directions. Do this, do this, do this, do this, and it happens. Okay, so there's not a lot of interpretation here. Only two things here. You should be able to implicitly differentiate a function, and you should know the difference between there, and there.
I do.
Especially on your college applications. I'm just saying, you can do whatever you want, but
Not that.
if you want to go to college there, you might want to make sure you know the difference.
Example, let's say college.
Okay, so I'm going to skip this slide and show you first the first example that we're going to do, and then when I show you the steps, it'll make more sense. So here I have a function, and you'll notice that there are y's and x's all messed up. It's not y equals, it's y squared, or y cubed plus y squared minus 5, blah, 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 blah. There's y's all mixed up in there. Do you know of any way to get those y's out of there?
Painful algebra.
I'm sorry?
Painful algebra.
Okay, and what would that look like?
A lot.
I have no idea how to get y by itself. I'm sure there's some sick and twisted way to do it,
Yeah.
but I don't know how to. Yes?
Do we want to get all of the y's out of there?
That would be our ultimate goal, but it's not very easily doable. So that's where we're going to use implicit differentiation. Implicit differentiation comes in when you cannot isolate the y's alone. Every function we've had up to this point has been y equals blah, 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 blah in terms of x, where we just take the derivative and we're good to go. This is a different scenario. Okay. Again, we can't get y by itself, so we're going to take the derivative of that whole shooting match. Initially, you won't have to worry about it. It'll just say use implicit differentiation to find the derivative. But eventually, you'll get to a point where you're going to have to, thank you, you're going to have to recognize when you need to use implicit differentiation. So that's easy. When you can't isolate the y's, you go to implicit differentiation. Okay, that's where we're going to use it. This is how we use it. That might be a good idea to write down, yeah.
So these were together with explicit or no? That was together.
They probably are, I just never use that terminology. It would make sense, the opposite of implicit is explicit. Step 1 is the only calculus on that list of directions. Everything else is all algebra. So this should be easy peasy. And the only thing I'm going to change from those directions is I'm too lazy to write out dy dx, so I'm going to write y primes instead. You'll see when I get into the example. Okay, we good?
No. No.
How about now?
No.
Yeah. Nope.
Work faster.
Don't you dare.
So there's extra words in that. It's math, you don't need full sentences.
Wow. Excuse me, sir. Okay. Go back to this.
What?
Back one slide. See how it is. You write every word.
And she's drawing a rectangle and she's coloring it in brown. And the font matches. Did you also get the bold in there too? Did you bold those?
Definitely did.
Awesome. Okay, let's do this. Well, actually, you watch me do it.
How much room do we need roughly of space?
I need about this much space. Here we go. What's a derivative of anything raised to the third power?
2 per second following.
Okay, so we're going to treat y as a variable. 3y squared. Easy, right?
Yeah.
Okay, does anybody not see that as easy? The only thing you need to remember when doing implicit is x is not our variable. We're taking the derivative with respect to x. So when you take a derivative of y, when you're done, you have to stick a y prime on the end of it. Okay, that having been said, Mitch, what's the derivative of y squared?
2y.
Attaboy. And what's the derivative, Jackie, of negative 5y?
-5 y prime.
Well done. And what's the derivative, John, of negative x squared?
Negative x squared, or it's still 2x? Negative 2x?
Negative 2x. No x prime. That doesn't make any sense.
Wait, could you explain why that is again?
This is saying I took the derivative treating y as a variable, but y is not my variable.
Okay.
So I got to stick a y prime on it.
Okay.
Here the variable is x, so it's just a normal derivative.
Oh, okay.
Now the kicker. This is the most common mistake that people make in implicit differentiation. What's the derivative of negative 4? 0. Good. I cannot tell you how many times people screw that up.
They should leave it as -4.
Or they make it negative 4 y prime, or they, I don't know. We're done with the calculus. That's not so bad, right?
No.
No, good. Now we do algebra. Whatever has a y prime on it stays on the left or moves to the left. Everything else goes to the right. 3y squared y prime plus 2y y prime minus 5y prime is equal to 2x. Again, not too bad, right? Yeah. Good. Factor out a y prime. And what's the last step? Divide. Y prime is equal to 2x divided by that big mess. All done. Pretty painless, right? Yeah. Just take the derivative, and again, if you take the derivative of anything that's not an x, you got to stick a prime on the end of it, a y prime or a z prime or a q prime, depending on what variables we use. Max.
Are we ever gonna have to like simplify that?
You can't. That's it. You may have to plug in values for x and y. We'll get to that later. You may have to do some other fun stuff. You want to do something fun?
No.
Yeah.
This will be fun. Let's do this and let's do this. What if we need to find the second derivative? Yeah. Yeah, get rid of this. So the first derivative was y prime is equal to 2x divided by 3y squared plus 2y? Plus 2y minus 5? Okay, there's the first derivative. How do I find the second derivative?
Take the derivative.
Matt.
Take the derivative.
Beautiful. Let's do the left side first because that's the easier part. What's the derivative of y prime, Matt?
Y prime. Y, I use 2 dashes.
Y double prime?
Yeah, a double prime.
All right. Want to try the right side, Matt? What am I going to have to use?
When 2x just become 2, and you do the new. Oh, you're gonna have to use chain rule, maybe. Okay. Follow triangle.
Quotient rule. The bottom squared. Bring that up to the top. Times the derivative of the numerator, which is 2, easy, minus bracket, the numerator, times the derivative of the denominator, which is
6y plus 2.
No.
Wait, what? Oh, it's 6 y prime plus 2y prime.
We good? Good, we're not done. What else could I do that would make you not happy? Could multiply the top out. It's worse than that though. No, that would. I hadn't thought about that, but that would be bad. I'm just talking about this right now. Would you like a hint?
Yes, please. I don't think I do.
Oh,
Back around.
Nope.
Solve for y.
No. Because I don't care what y prime is, because I'm looking for y double prime. I got it.
Oh,
Turn-
plug it in.
Yeah, plug it in. 3y squared plus 2y minus 5 times 2 minus 2x times 6y times 2x over 3y squared plus 2y minus 5 plus 2 times 2x over 3y squared plus 2y minus 5. All of this over 3y squared plus 2y minus 5. Quantity squared.
Why would you do that?
Wait.
I didn't even work on the first one.
Can I go get the dog now? Okay, great.
Yeah, I just worked for a counselor.
I don't have enough
Oh,
room.
wait, hold on. Sloppy.
Don't have enough room.
There we go.
Stop slacking.
Hang on, Mark. Can I borrow you for 1 second?
Excuse me, everybody.
Keep them.
Talk amongst yourselves. Question to ask yourself while I'm out here is, that's not an acceptable answer. What's wrong with that answer?
It's not acceptable.
So,
I ran out of room. Worst, just get rid of the bottom.
I would just be crying.
I have questions.
Yeah,
going this one about it.
Really? Mine are super loud, which is really unfortunate.
But then the best is that he's spending
Yeah.
hours that he was figuring out.
Ah, well.
Seem to not make you several.
Yes.
You're not solving for why. I just sold the lies are like February because. I took her dad one.
That's what Mila was saying too. I don't know. Maybe yours will update in a week.
Well, let's see. But then again, she also went. I don't know if environment.
Yeah, maybe. Right, see, like my English class has switched. So it's like they switched between. So yeah, no, I'm not.
Wait, you guys know your
Yeah.
Yay!
Oh, wait, I
have a phone.
Yeah, so it's like you're on like a type So this is just
Okay, what's wrong with that answer? Abby?
There's two variables. There's fractions.
Normally that would bother us, but it's the fractions it's the fractions within the fractions that are a big no-no. When we're simplifying, there's two things we're concerned about. One is no negative exponents. The other one is fractions within fractions. So, how do I get rid of the fractions within fractions?
Just erase them.
Just erase them. Good. Nice. I'm going to multiply this whole thing by 3y squared plus 2y minus 5 over 3y squared plus 2y minus 5. Is that a legal move?
Yeah.
Why?
Because it's multiplied by one.
Multiplying by 1. Now you got to be careful when you do this. I would love to move this onto another screen, but I'm going to actually move up and then once it, yeah, this is going to get ugly. Okay, so I'm going to take this mess and multiply it by the first thing. So the first thing's easy. That just becomes 2 times 3y squared plus 2y minus 5 quantity squared. That's this. Times that. Okay. Now, if I take 2x times the 6y blah blah blah, and I multiply it by this, I'll end up with 24x squared y minus 24x squared y. We good with that?
I need a minute.
Yeah.
Distribute the 2x to this business, multiply this business times that guy. The things on the bottom cancel out.
Alright, I think I need a
So the last one would be minus 4x, 8x squared, just 8x squared. 2 times 2 times 2, x, x. And then this goes away.
Why is it 2 is there? Because the 2x at
Yeah.
the beginning of that whole mass
Yeah.
is
Oh, that
multiplied
2
by the
Yes.
numerator over there.
But
So
there's
like,
no X in that.
what?
All of that over 3y squared plus 2y minus 5. Now this becomes
And then small ones, then
cubed.
so then it's 2x and then it's multiplied by 2x.
Okay. Yes, sir.
Now, from the beginning, could we have just taken the bottom and put it on top to the negative first power and done chain rule?
Definitely. Could have done product rule with chain rule. I don't know which one would be more funner,
Yeah.
but still be ugly. There's not much else you can do with that monster up on top. You could multiply out the trinomial squared, but I don't really want to do that.
That sounds fun.
So I would leave it like that, and remember that that equals the second derivative. We're not going to do that a lot, to be honest. What I did want you to see, however, is that when you take the second derivative and you have these y primes, we know what y prime is, so we can sub in for that y prime. Question?
I don't want to be that kid, but where would you use this in real life?
In about a week and a half or so when you take the test.
Okay. Sorry.
Good answer.
No, I was just curious. I'm honestly curious. That wasn't like, when will we use this? Like.
So you just at the grocery store when you're
Yeah.
when you're looking for when you're trying to decide the expiration date of a gallon of milk.
Use
Or you can
implicit
read
differentiation.
Read it.
Okay, that was fun, right?
Let's do it again.
Okay, funny you should say that. Yeah, we did that. Okay, let's do it again. Find the slope of the tangent line. How do I find the slope of the tangent line? Derivative. Can you pull the y's out of there? No. Just because the last one seems so much fun for you guys, I decided to make this one equally fun.
This one was worse. You're too kind.
I'm a giver, not a taker. What's going to happen on the left side of this derivative? Good. Death, crying, dog petting. Sure.
You need a dog just in every calc room. Yeah.
You just keep one in the closet overnight.
Yeah.
Well, no, you would take it home. I'm not saying.
Oh,
you
we're
should,
not
like,
saying
keep
leave
a
it
dog
here.
or
We
something.
could leave it
Can we have a
here.
count
What kind
guinea
of
pig?
person are you?
Go
I'm not
count.
barbarian.
Why guinea pigs?
It's amazing that you children survive in my house.
It is.
No, the garage though, a couple nights. They learn to snuggle up with the snow blower and the lawnmower.
That's nice.
What's gonna go on in the left side of that equation?
Well, there's chain rule.
Bingo. What's gonna happen on the right side? The prime thing? Yes? The implicit difference, along with what other rule? Product rule. Very common mistake is people don't see this left side as B, that's the right side, sorry, go like this, L right. See that as a product rule. Shall we begin? Yes.
How did you differentiate between?
Calculus fun.
Yeah. How did you differentiate between like using implicit differentiation or any other type of?
You will use implicit differentiation when you cannot get y by itself to start the problem.
So if you have like an x and a y.
Yeah. Well, they all have x's and y's, but the ones we've done up until today have always had y equals on one side and then all the x's by themselves on the other side. This, we have a mishmash of x's and y's together. Okay, here we go.
Nice to meet you.
What's the derivative of the left side?
6, did someone say?
6.
Adam, you go. Left side.
The derivative of the left side, 6.
Good start. I'll give you this. I'll give you the parentheses for free.
6x squared plus y squared. No. 6
Almost perfect, you missed something. When you took the derivative of y squared, you get 2y, but then because you took a derivative of y, you got to stick a y prime on it. Well done, let's give it up. Okay, Mercedes, you have the right side.
I have not finished the right side yet.
I understand. While you're finishing, I'll talk to the masses here.
Okay.
When you get to a problem like the right side, you have to make a decision on how you want to handle that. You can handle it like this and say, well, that's 100 times the derivative of x times y. Or you could do it as the derivative, attach the 100 to the x times y and do product rule that way. I personally like to attach the 100 to the x, but you could do it like this also. The reason I don't like the first one is because sometimes you make mistakes when you're distributing and doing all kinds of other stuff. It's pretty hard to screw this up.
You say that.
Yeah, now I cursed her. All right, Sparky, what do you got?
100 x and then 1. Well, it's times 1. Minus y prime thing. Y prime. I don't know. I'm done.
It's a product rule, right?
Yeah.
So we're doing 100x times y. Those are our two terms. Okay, so you did the first times the derivative of the second. What's the derivative of y?
1
1
y
prime plus the first. Nope, so you did that right. Derivative of the first, which is 100,
Yeah.
times the second. Okie doke. How are we doing so far?
Excellent. Stop.
Now we have another crossroads. Since I'm looking for the slope at 3, 1, I don't really care what the derivative is. I don't have to solve for y prime. I will eventually, but it might be easier in this case to plug and chug 3 and 1 in there first and then simplify. If you want to solve for y prime, you can. It does get ugly, but it's doable. It's easier in this problem, I think, to plug in 3 and 1 first. So we would get 6 times 9 plus 1 times, that's 9 times, oh no, that's just an underline, right?
Oh, we're multiplying.
So that's 6 plus 2 y prime equals 100 times 3, which is 300 last time I checked, y prime plus 100. I think I got it all right.
How did we get that?
Plugged in 3 for x and 1 for y.
Oh, yeah, that makes sense.
Okay, so that's 10 times 6 is 60, times 6 is 360, plus 60 times 2y is 120y prime, equals 300y prime plus a hundo. That's a lot easier than solving that equation for y prime. Move everything with a y prime to the left. Negative 180y prime is equal to, move everything else to the right, negative 260. So y prime, I should say, is equal to negative 260 over negative 180, which is 260 is what? 13 ninths. 13 ninths. Is that right?
Yeah.
Wait, where did you get 6 from?
Which 6?
Where it's by the.
This 6?
Yes,
2 times 3.
but isn't it a square?
No, this is a squiggly. I underlined
Oh.
the
Oh.
here.
That makes a lot more sense.
Oh,
Sorry.
No, just like, it's a funny sound.
I get it.
Okay.
For now.
So like I said at the beginning, it's algorithmic. You do this, you do this, you do this, you get your answer. Now this being, take the derivative of both sides. Anytime you take a derivative with a y in it, you attach a y prime. Be careful to look for quotient rules, product rules, and chain rules. isolate the y primes on the left side, bring everything else to the right, factor out a y prime, solve, and what you're left with is the derivative. Frankie?
Where'd you get the 120 y prime from?
9 plus 1 is 10 times 6 is 60, and then distributed that to the 6 and to the 2y prime.
Were you ever switching around, like your, every time you took the differentiation of an x, it would be x prime?
That does pop up, but not for us. Yeah.
Okay, as a more general question, when you're doing like the chain rule in combination with the quotient rule or the product rule, what do you do first? If that makes any sense.
Depends on the problem.
Okay. Alright.
Some of them you do the power rule first, then chain rule. Sometimes you do the product rule first, then it depends on the problem. It changes from problem to problem. Okay. Questions here? Can I erase?
Yup.
Okay, now look at that for a second. And let me ask, how many of you do not see anything moving? You all see something moving.
Well, I know it's. What if it's actually moving? It's just a GIF, and you're messing with us, saying that it's an optical
It's not.
illusion.
Yeah, I don't like that.
But you see it moving.
Yeah.
Okay. Usually about 2 or 3 people per class will not be able to see the optical illusion. You don't see anything moving?
It's not moving.
Okay, there's one. Anybody else want to cop to it?
Only when I move my eyes.
Yeah,
See
only when you
nothing?
move your
Well,
eyes.
if you look at one spot, then it's not.
Yeah, if you look at
Yeah,
one
if you
spot,
move your
it
eyes around, then
stops.
it starts moving.
If you stare at one, then it stops.
Yeah.
I still see it moving when I stare at one.
If you unfocus your eyes, it doesn't move.
They're all.
Okay. That could be true.
I'm gonna go with